The topic of this video is section 3.2.5, reduced row echelon form. Gaussian elimination involves reducing the augmented matrix of a linear system to row echelon form and solving the new corresponding system using back substitution. We will now consider a method of reducing the augmented matrix even further to simplify the back substitution step or even remove it entirely. Let's look at definition 3.2.8. A matrix is said to be in reduced row echelon form, or RREF, if the following three conditions hold. The first condition is that the matrix is in row echelon form. The second is that the leading entry in each non-zero row is a 1, called a leading 1. And the third condition is that each row containing a leading 1 has only zeros above and below the leading 1. Let's look at example 3.2.13. We want to determine whether each of the following matrices is in reduced row echelon form. Let's look at part A. We want to check all three conditions. First, we want to check if this matrix is in row echelon form. And so we need to check if there's a row containing only zeros. There isn't. Then we find the leading entries, and we notice that we do have that the leading entry in each row is to the right of the leading entry in the row above it. And so this matrix is in row echelon form. We move on to the second condition. Do we have that every leading entry is a leading 1? We do have that in this case as well. Do we have that each column containing a leading 1 has only zeros above and below the leading 1? We do have that as well in those first three columns. Each column only contains a leading 1 and zeros. So the third condition is also satisfied, and so this first matrix in part A is in reduced row echelon form. Let's look at the matrix in part B. First, we want to check if this matrix is in row echelon form. And we notice that there is a row of zeros in the matrix, which is not below every row containing non-zero entries. And so this matrix is not even in row echelon form. And so the first condition is not satisfied. And so right away we can say that this matrix is not in reduced row echelon form, since it isn't even in row echelon form. In part C, we have a new matrix. We want to check each condition. Is the first condition satisfied? There's no row consisting entirely of zeros. Where are the leading entries? Here they are. We do have that the leading entry on the second row is to the right of the leading entry on the first row, and so the first condition is satisfied. This matrix is in row echelon form. Is the second condition satisfied? Are the leading entries all leading 1s? Yes, they are. Is the third condition satisfied? Do we have that each column containing a leading 1 has only zeros above and below the leading 1? We don't have that. In the third column, there is a leading 1, and above it, there is an entry that is not a 0. And so the third condition is not satisfied, and so this matrix is not in reduced row echelon form. If that 3 was a 0, the matrix would be in reduced row echelon form, but it is a 3. Moving on to part D. Again, we start by checking the first condition. Is this matrix in row echelon form? There's no row consisting entirely of zeros, so we move on to checking the leading entries. Here are the leading entries of this augmented matrix. And we do have that the leading entry on each row is to the right of the leading entry on the row above it, and so the first condition is satisfied. Is the second one satisfied? We do have that all leading entries are leading 1s. Is the third condition satisfied? do we have that each column containing the leading one has only zeros above and below the leading one? Well, if we look at the fourth column, it contains a leading one, but it does not have only zeros above and below the leading one. It has two non-zero entries above the leading one. And so again, condition 3 is not satisfied, and so the matrix in part D is not in reduced row echelon form. What do we have in part E? Well, let's check the first condition. Is this matrix in row echelon form? There's no row consisting entirely of zeros, so we move on to identifying the leading entries. They do satisfy the condition that the leading entry on each row is to the right of the leading entry on the row above it. And so the first condition, the condition that this matrix is in row echelon form, is satisfied. What about the second? Do we have that every leading entry is a 1? We don't. The leading entry in the second row is a 2, and so the second condition here is not satisfied. And so the matrix in part E is not in reduced row echelon form because the second condition isn't satisfied. Finally, let's look at part F. And we want to start by checking the first condition. Is this augmented matrix in row echelon form? Well, there's no row consisting entirely of zeros. So let's move on to identifying the leading entries. Here they are. And we do have that the leading entry on the second row is to the right of the leading entry on the first row. And so condition 1 is satisfied. Condition 2 is also satisfied because both of those leading entries are 1s. And finally, is condition 3 satisfied? Well, do we have that each column containing a leading one has only zeros above and below the leading one? We do have that. Both the first and the fourth columns contain only the leading 1 and 0. And so the third condition is satisfied. And so this matrix in part F, this augmented matrix, is in reduced row echelon form. And finally, unlike row echelon form, the reduced row echelon form of a matrix is unique. There's only one reduced row echelon form of a matrix.